The following content is supported by victoris.org.
So before I talk about functions, let's talk a bit about the philosophy of functions. Why do you need to have functions? So you think about it. What do you do in the morning routine? You wake up, right, and then you go brush your teeth. And brushing your teeth consists. So every morning you do that same routine over and over again, right? And that routine consists of sub routines as well. For example, when you brush your teeth, you need to maybe you take a toothbrush out of the place. There's the cup. You wash your toothbrush, then you open the toothpaste. You put the toothpaste, then you start brushing, right? And then um so the whole point of functions is that when we have code that is going to be executed many times, right? We don't want to write the same code many times and repeat ourselves. So we put the code in a function and then we just call the function. So yeah, we'll get to the details now with the Kahoot. So any point if you're in time when you're confused, you can always type it out in the Replit. You can open it up and type it out. It's okay if you get I recommend you type it out if you're not sure what's going on. Remember, this space over here is important. It's part of the indentation, similar to conditionals. Makes sense?
Hi.
Yeah. Okay, awesome. So she says hi. So why does it say hi? Okay. Okay, so what happened over here? The first line over here, we write def is telling Python we're defining a new function. And then say hi is the name of the function. We can call it anything else we want. We can say bye or any. We can call the function names convention follows the variable names convention. So we can use underscore. It's case sensitive. Yeah. And then now to define a function, we say df, the function name, and then after that we need to put round brackets. Inside this round bracket, later on, we're going to put in parameters, but more on that later. So for now, there's no parameter that takes in, and then we need a colon. So similar to conditionals, right? Whenever we have a colon, the next line will have these two spaces. We have a empty space, and that tells Python that whatever code that has this empty space before it is part of the function. It's defined inside the function block. So inside the function, I can have any code I want. Print hi, I can have x equals to 5, print x, any valid Python code inside the function. In this case, since lines 2, 3, 4 have the spaces before them, they're all part of the function. Okay, and okay, so let's just erase this part for now. Then now, right, you see that line 4 does not have the space. So line 4 is, in this case, line 4 is not part of the function. Line 4 is outside the function. Okay, so what happens over here is that when we declare a function, we're saying the say hi function has the following code inside: print hi, line 2. Then the function by itself it doesn't execute the code inside the function. When we define the function, it's just saying this code is part of the function, but the code inside the function doesn't run yet. So the function is sleeping until we call the function and say wake up, run your code, and then it'll wake up, it'll run all the code inside the function, and then it'll stop. So in this case, we call the function once. So the code, it was like line 1, define function. Line 2, the code inside the function is defined, but it hasn't executed yet. Line 3, line 4. Line 4 calls the function, then line 4 goes to line 1, goes inside the function, goes line 2, print hi. Okay? So now you may probably guess, wait, what if they call the function twice? Right? Now you can try to guess. You can try typing it out and okay, great. So it says if we run this, it will say hi, and then there's a new line and then hi. Okay, so what's going on over here? We declared the function. We called the function once, it printed hi once. We called the function another time, it ran the code inside the function again. Over here, I did not write print hi, right? I just called the function only, right? So now maybe you want to guess what happens if we do not call the function at all. Right, we just have defined the function and say hi. So if you just define the function, there's no output. If I run this, you see there's no output at all. It finished executing already. Okay, so the lesson to take away from here is that the function, when it's defined, the code inside the function is part of the function, but it does not run until you call the function and say wake up, run your code. Okay. Yeah, so the code inside the function right now is a very simple function, but we can have much more code inside the function, and as the function gets bigger and bigger, you realize that we just have to write one line of Python in order to execute the whole chunk of code. Yeah, so now we don't need to repeat ourselves that much. Okay, so the general syntax of a function is df, the function name, round brackets, colon, and then the code inside the function has the two spaces, has an indentation, and this is code that's inside the function. Okay, so now perhaps you might want to so yeah, this is just another example. We print minding my own business. You see test, the test function was not called, so inside was never printed to the screen. Okay, and then if we call the test function, then we see executes print inside. So you see, even though print inside kind of looks like it came before print minding my own business, right? You see that minding my own business came first, and then inside appeared, because this print did not print, is inside the function, so it's not executed when the Python scrolls past it. Only when you call the test function, then it jumps into the function, executes. Okay? Yeah. Okay, so we can have some other code and then test again. You see the output. Make sense? You can call it as many times as you want. The function will obey you. Okay? Okay, so you can try typing out the following code. Okay, great. It says 9, right? Okay, before we jump to what the code does, I'm just going to modify the say hi function a bit. So let's say I have say hi over here. Okay, if I run this, it just says hi. But if what we want to personalize, what we want to customize the function a little bit to say hi to a person instead. So I want to basically say hi Tom. Okay. So what if I want to do that? I can say hi Tom. That works, right? Now it say hi Tom. But then what if I want to change Tom to Jerry? Then I need to change the code. Hi Jerry. But what if I want to call say hi twice? What if I want to say hi twice, but the first time I want to see hi Tom, second time I want to see hi Jerry? It's like I cannot really do it, right? So what I can do now is, that's where function parameters come in. So if you think of a function like a factory, every time you call it, it does a certain sequence of code, right? So functions can take in inputs. It can take in like settings of sorts into the function, and that's where the parameter here comes in. So let's say, right? So what if I say hi Tom and hi Jerry, right? If I want to, I can create a variable called name equals to Tom. So if this, another way of saying hi Tom is to do this, right? Makes sense? So right now, if I print, it just say hi Tom twice, right? If I want Jerry, I change this to Jerry, then it'll say hi Jerry twice. But this variable over here, I want it to have different values for each time I call the say hi function. So what can I do? I'm gonna remove this variable. Okay, the name variable is not defined at the moment. If I run this, it's gonna have an error. It's saying name is not defined. So what I can do, I can put the name over here, right? And then inside, when I call the function, I pass the names into the function. So if I say hi, I pass the name Tom, right? Tom will go into the variable name, and it says hi name. And if I pass a Jerry into the function, it goes in the variable name, it says hi Jerry. So if I run this, it says hi Tom, hi Jerry. Make sense? Okay, so are you confused?
Yes.
Okay. So where were we previously? Okay, so we define a function. The function has a name of say hi, and it takes in a parameter called name. Okay, this is a variable name. Is a variable. This name is a variable that we need to pass into the function. So whatever value we pass into the function, let's say we call say hi with Tom, this value will be stored in the variable name, and then it'll execute line 2. What's the value of name when we do the first call? So Tom goes into the variable name, and we say hi name. So what would it print?
Oh.
It'll say?
Yeah, it will say hi Tom.
Yeah, correct.
When do you need to do that? Why can't you just... How does this simplify the process then?
It simplifies the process because now actually it doesn't simplify anything. It now makes it possible that you can have the function inside run with some custom settings of sorts. In this case, the setting was name. So if in the first, let's say I copy this code, right, and I do over here hi, let's say Alice, and I call hi Bob. It's gonna say hi Tom, hi Jerry, hi Alice, hi Bob.
But when do you need this?
You need this because right now if the function didn't take in any parameters, then every time the function runs, it's running the same lines of code. It's just running the same same lines of code again and again, right? But this allows you to have a level of customization of each time I run the function, I want to do it a little bit differently.
Okay.
Yeah.
But then you have to predefine what you want to.
Yeah, you have to
Okay.
predefine what you want the function. You have to decide on what settings to pass into the function.
Okay.
In this case, you pass the function is a variable called name. Then I pass in the value of name into here. Okay, can.
Yeah.
So let's jump back to the code over here. So in this case, we had a function called define square. We have a function called square, right? And it takes in a parameter x. Then I have colon, and once again, whenever we have a colon in Python, it means that we're indicating there's a block of code. So in this case, I print x times x. Okay, and then now I call square of 3. If I run it, 3 goes into the value x. So the value 3 goes into the variable x. It prints x times x, which is 9, right? And then it says 9. So what if I call the function with a different parameter? Okay, great. So it says 25. Why is that so? It's because I put 5 over here. The value 5 is passed into the square function and is stored. This value 5 is stored in the variable x. It's effectively saying x equals to 5 when we call the function. Then since x is 5, print x times x gives you 25. Okay, just yeah. Okay, so what if we pass in 2 parameters into the function? Maybe you want to give it a try. Okay, right, great. It says 6. So do you understand why it says 6? Yeah, because so I have a multiply function. It takes in a and b and prints a times b. In this case, if I call multiply with 2 and 3, 2 goes into the variable a, and what's the value of b? 3. Then it prints a times b, which is 6. Okay. So yeah, is this example, the math example, clearer, or the name example clearer? Just wanted your feedback.
This one.
This one clearer. Okay, sure. Okay, yeah. So okay. So that's for functions. Now we have covered functions. We covered how to call functions, right? And we've covered how to pass in values into the function to tweak the settings of the function. You can think of the function as a factory. But what if so these are all these are all routines of sorts, and functions can actually call functions as well. Okay, so this is useful and all, but if let's say, right, if multiply, so we have the 2 functions, you're familiar with them, right? Okay, so we can define multiple functions also. So in this case, we have a multiply function, then I have a square function that takes in variable n, print n times n. Okay, and then I do this and I square 6. The answer is just going to be 6 and 36, right? Okay, so what if, let's say, I want to take the result of multiply 2 and 3 and feed it into the square function. So let's say I change this to 2 and 5. So 2 times 5, I want to feed the result of 2 times 5 into the square function. I want to say square of 10. Right now, if I now this will say 10 and 100, right? But if I change this, let's say I change it to 4, I want the result of this function, which is 8, right, to go into, right now I have to manually change it to 8, right? Right. What if I just want to do it automatically? So the problem right now is that when we print something to the screen, it just prints it to the screen, and then this a times b value is, when the function exits, it just fizzles out, like it's just lost. The information of what I pass into the function and what computation has happened inside the function is just lost. So I want a way to let the function return a certain value back to my caller. So okay, so what can I do? You try typing out the following code. Okay, so similar code as just now, but instead of printing something, we just see return. Do you see the output? Yeah, okay, so you see 6, right? So why is the answer 6? Okay, so what happened over here? Okay, so I have my multiply function, but you see that instead of writing print a times b, I return a times b instead. Okay, I'm just gonna comment out the square function for now. Okay, now if I write multiply 2 and 3, can you guess what the output of this is going to be? It's a trick question. If my thing is 6, right? If I run it, you see, actually there's no output. So what happened over here was 2 and 3 went into the function, in the parameters a and b. It returned 2 times 3, which is return 6. But nowhere here did I state print 6 to the screen, right? So what happened was return 2 times 3. Now we may be thinking, then isn't the function useless? No, not at all, right? In fact, the function has become even more useful, because now what return 2 times 3 did was it basically replaced this entire function call, right? We called the function and to execute the code. Replace this entire, when we return a value, it's effectively saying this entire function has the value of whatever was returned, in this case 6. So it's as good as saying this entire function is replaced with 6. Yes, the function now has a value that it returned. So 6 alone, this code, if I run this, 6 alone is just it's not printed out to the screen, right? Just how we write like a value. We just write a value like that. Python just goes past it. Doesn't print anything to the screen. So what we can do, right, is we can do print multiply 2 times 3. Now we see 6 appear. Make sense? Because return 6, right? So this entire thing is replaced with 6. Print 6. Okay, but that's even more useful now, because now instead of just printing it directly, I can can write x equals to this thing. Now this function has the value of 6. It's saying x equals to 6. It's assigning the variable x the value of whatever the function returned, in this case 6. And now I can do whatever I want with the variable x. I can do print x. Now we see it says 6 appear, but that's not, we don't need to stop there, right? We can go on and do other stuff with 6. We can say x equals to 2 times x. And then now it print 12. We can do whatever we want. So by replacing this the print just now with a return, we have effectively made the function way more powerful, in that whatever results it computed, all the hard work that the function went through, now we can return the value into the main code, right? And do whatever we want with it, manipulate it using variables. Yeah. So this concept is something that most students would struggle to understand when they first learn it. But okay, so let's take a look at the code here. If you're unsure, you can always type it out. Okay, awesome, 36, you got it correct. So you guessed it correctly. So maybe you want to explain what happened over here. Do you want to try?
Okay. From my understanding is that here the x is equals to 6.
Correct. Yep. Line 7's x will be 6.
Then in here it is run.
Yeah, correct.
Lines.
So it calls the function.
Yeah, then the x becomes 6 times 6.
Correct. Yeah.
Then the print x will be 36.
Exactly. So the current if we stop at line 7, right? Cut in between lines 6, 7 and 8. The x has a snapshot it. X has the value 6, right? Then we write x equals the square of x, and this is value of x is here is 6. So it's saying x is square of 6. So 6 goes into the square function. It returns 6 times 6, returns 36. Square of x now becomes replaced with 36. So x equals 36, and we print. That's what I get. Okay. So that's the power of returning a value instead of just printing to the screen. Yeah, if you've gotten it, it's very good, because a lot of students, they are very confused by this. Why we need to return something instead of printing it? Yeah, we can do much more things when we return a value than when we just print it to the screen. Okay, so good job. You got first place. Yeah. Okay, so if not, then let's go to the replit exercises. Okay. And we will Yay. Okay, let's go over to Replit.